All right, so now we're going to do some problems that involve math. So we're going to start off with some weight problems. So remember that weight is another type of force. Okay, so Newton's second law basically says that the greater the force, the greater the acceleration. So the harder you push something, the faster it's going to move. And the greater the mass, the less the acceleration. So the heavier something is, the slower it will move. And mathematically, Newton's second law is basically force is equal to mass times acceleration. So mass and weight are not the same thing. Weight is equal to the force of gravity. So in every time that we've done free body diagrams where we have listed F of G, so let's do an example of that. So if we have some object and we're resting it on the ground and we've talked about the F of G, the force of gravity pulling it down, that is the same thing as weight. Okay, so really when we're looking at weight, we are accounting for the mass and we're also looking at the force due to gravity. So remember that force is equal to mass times acceleration. So F of G, or the force of gravity, which is the same thing as weight, is nothing more than a force. So to get force of gravity, we would still take the mass and multiply it by the acceleration. Now, the acceleration due to gravity is special because it's 9.8 meters per second squared. So it's something that we know. If we're looking at weight, basically, we take the mass and we multiply it by 9.8 meters per second squared. Now, in the last unit, I told you guys to assign a negative value to the acceleration due to gravity, and really we're just accounting for the direction of the acceleration. In this case, go ahead and make it a positive value. So to calculate weight, we're going to take the mass of the object and multiply it by 9.8 meters per second squared. That is all that weight is. It's the mass times acceleration due to gravity, which is specific, it's 9.8. Okay, so let's do a few problems. So, a boy has a mass of 50 kilograms. What is his weight? So remember, the force due to gravity is the same thing as the weight. So we know that force is equal to mass times acceleration. If we have force of gravity, that is equal to the mass times acceleration due to gravity, which is going to be 9.8. Okay, so we know that the acceleration is equal to 9.8, and that's an A to the G, so it's acceleration due to gravity. So I know that the acceleration is 9.8. I know that my mass is 50 kilograms here. So I can go ahead and solve for F of G, which is the same thing as weight. So the force due to gravity is equal to 50 times 9.8, which is about 490 newtons, I believe. So yes, 490 newtons. And it's okay that our weight is in newtons. Newtons can be a unit of weight. Okay, so his weight is 490 newtons. And certain problems you might get a question asking for his weight in pounds. You would have to know a conversion factor for that. Alright, so let's look at another problem. It says an object exerts a force of 40 newtons on the ground. What is the mass? So first of all, if the object is exerting a force of 40 newtons on the ground, really what we're talking about is the force due to gravity, which remember is the same thing as weight. So the force due to gravity is 40 newtons, and we're looking for mass here, but we don't know the acceleration, but we really do though. Because force due to gravity is equal to mass times acceleration, but we're dealing with the acceleration due to gravity, which is 9.8. So acceleration is 9.8. So we know that force due to gravity is equal to mass times acceleration. So let's go ahead and plug it in. 40 newtons is equal to the mass, which is unknown, multiplied by my acceleration, which is 9.8. Divide both sides by 9.8. I get my mass, which is 5 something, I believe. Okay, so 40 divided by 9.8 should give me 4.08. And we are talking about kilograms here, because remember, we have newtons, which is kilogram times meters per second squared. We get rid of the meters per second squared here, and then we're left with kilograms. All right, so let's look at something else. All right, so Tina exerts 513.4 newtons of force. What is her weight in pounds? So we're looking for weight in pounds, and the information that it tells you is that 1 pound is equal to this many kilograms. So let's pull out the information and see what we're looking for. We're looking for weight here. It says that Tina exerts 513.4 newtons of force. So if we're just talking about her exerting a force and she's just standing there, we're really talking about F of G. So technically, I do have her weight. It is 513.4 newtons because she's just exerting this force by standing there. This is her weight, or her force due to gravity. The only problem is it's asking for weight in pounds. So if we had a conversion factor, I could take my newtons and go to pounds, but I don't know how many newtons are in a pound or vice versa, really. It doesn't say here. So it does give us this information that's saying 1 pound is equal to 0.45 kilograms. So just knowing that, I would want to go ahead and get my mass. My mass will tell me how many kilograms I have here. Then if I have kilograms, I can go to pounds from that point. There is another way to do this, but I'm just showing you this way given this information. All right, so because we're talking about force due to gravity, the acceleration due to gravity is 9.8. We're looking for mass here, again, to get pounds. So force due to gravity is equal to mass times acceleration due to gravity, but it's 9.8 in this case. So 513.4 is equal to the mass times 9.8. Okay, so divide both sides by 9.8. (513) divided by 9.8 gives me about 50, I believe. So yes, 52.387. And I'm not rounding here because I've got one more step to go, so I round at the very end to prevent any rounding errors. Okay, so my mass is 52.387 kilograms. I'm looking for pounds though, so I'm going to go one more step. Kilograms will go on the bottom, pounds will go on the top. 0.45 kilograms is equal to 1 pound. So that divided by 0.45 gives me roughly 116 pounds. So this is just one of the ways to look at the problem given this information. So remember, weight is the same thing as force due to gravity. And technically it does give her weight here, it just gives it in newtons instead of pounds. So if we wanted to, we could convert from newtons to pounds.